Problem number 42nd, part A and part B from chapter 26. Copper and aluminum are being considered for a high voltage transmission line that must carry a current of 50 ampere. The resistance per unit length is to be 0.150 ohm per kilometer. The densities of copper and aluminum are 8,960 and 2,600 kilogram per cubic meter respectively. First question, part A, compute the magnitude J of the current density for a copper cable. And the second question is, calculate the mass per unit length lambda for a copper cable. And for part C and part D, I am going to make a separate video. So here, the part A and part B is related with the copper cable, and the question part C and part D is for the aluminum cable. That's the reason I'm going to make a separate video, because this question is a little bit lengthy. Okay. Now I'm going to write the given first, and after that I'm going to work out part A and part C. So what is given here? You have two cables, copper and aluminum, and the current is flowing through this cable, and the current information is given, I, which is equal to 50 ampere. And the resistance per unit length value is given, which is R over L, takes the value of 0.150 ohm per kilometer. Here we have to convert this kilometer in terms of meter. As we know, 1 kilometer, which is equal to 1000. By that we can cancel this kilometer with kilometer. Finally, we will get the resistance per length, R over L, which is equal to 1.5 multiply 10 power minus 4 ohm per meter. And also they gave the information about the density of the two material, copper and aluminum, but we need the resistivity also. The most important information in this question, the density and the resistivity will take the same symbol. So for that, I have to separate very clearly. I have to mention it very clearly, because in this question, we need the density of the copper, and also we need the resistivity of the copper also. So both will take the same symbol. So what I'm going to do, I'm going to write it separately. So resistivity of the copper takes the value of 1.69 multiply 10 power minus 8 ohm meter. Likewise, the density of the copper, so here this is the density value, better I can write here. So the density of the copper is equal to 8,960 kilogram per cubic meter. So both are different, but it take the same symbol. The first one is the rho, which refers to the resistivity rho, but here this rho is for the density. So while you substitute the value in the equation, you should be very careful. Clear? Okay. So now I'm going to find the answer for the first question. In the first question, we are going to find the current density of the copper cable. So part A, we are going to find the current density. As we already know the equation for the current density, J, which is equal to current over area. And for this area, I'm going to use the resistance equation, resistance R, which is equal to the resistivity multiplied by length over the cross-sectional area of the cable. So here I'm going to rearrange this equation in terms of area. Therefore, area A, which is equal to rho multiplied by L over resistance. Now I'm going to take this area equation and I'm going to substitute in the current density equation. By that, the current density equation is modified as J, which is equal to current divided by, this is the resistivity of the copper, right? So I have to write resistivity of the copper multiplied by the length divided by the resistance. So this resistance will go to the top. By that, the current density equation, J is equal to current multiplied by resistance divided by the resistivity of the copper multiplied by length. Now you have to see this equation, the resistance and length. We don't have this resistance and length separately, but we have the value of R over L, right? So now what I'm going to do, I'm going to substitute the value here. So here the current value is 50 ampere divided by the resistivity of the copper is the constant value, which is 1.69 multiply 10 power minus 8 multiply this R over L. Just before we convert this ohm per kilometer in terms of ohm per meter, so I have to use this value in place of R over L. So I'm going to substitute this R over L value here as 1.5 multiply 10 power minus 4. Here I got the answer for the current density for the copper cable. J is equal to 4.44 multiply 10 power 5 ampere per meter square. So this is the answer for part A, which is the answer for this is the answer for the part A. Now we have to go for the second question, part B. We just go back to the question to read what they need in the second part. They need mass per unit length. So mass per unit length is denoted by a symbol lambda. Clear? So we are going to find mass per unit length. So in the second part, we are going to find the mass per unit length. So for that, I have to use the equation for the density formula. What is the formula for the density? Density rho, which is equal to mass over volume. So don't get confused about this rho. Here in part B, here this rho is for density. So better I can put D here, okay? So rho, which is equal to mass over volume, I have to rearrange this equation in terms of mass. Therefore, mass, which is equal to the density of the copper multiplied by volume. I can write this volume in terms of area multiplied with the length, right? And the left hand side we have the mass. I'm going to move this L to the left hand side. By that we will get the mass per length, which is lambda. Here mass per length is nothing but the lambda. So M over L, which is equal to the density of the copper multiplied by the area. Now what I am going to do, I'm not going to touch the density of the copper, but in place of area, I'm going to use the equation of the resistance again, resistance R, which is equal to rho L over area. Therefore, area, which is equal to resistivity multiplied by length divided by R. So I'm going to substitute this equation here. So if you substitute, what we will get? Mass per unit length, which is equal to the density of the copper multiply with the resistivity of the copper multiply with the length of the copper cable divided by the resistance. So here we have L over R, right? But in the question we have R over L. That means it's the inverse value, right? So while you substitute the value here, we have to use the inverse of R over L. Now I'm going to substitute the value here. The density of the copper they gave in the question as 8,960 multiply the resistivity of the copper is 1.69 multiply 10 power minus 8 divided by the length over resistance, because R over L we got the answer as 1.5 multiply 10 power minus 4 ohm per meter, right? But here if you want to use this value here, it's the inverse value, right? So here I have to use this value as 1.5 multiply 10 power minus 4. Why? Because here we have L over R. R over L takes the value of 1.5 multiply 10 power minus 4. But here we have L over R. So we have to take the inverse of this value. Clear? So here I got the mass per length, M over L is equal to 1.01. The unit is kilogram per meter, which is equal to the lambda. So this is the answer for the part B. Clear? That's it. Thank you.